this episode, we're going to focus on a late-stage attacker goal that creates some of the highest real-world impact: data exfiltration. Exfiltration is the act of moving data out of an environment without permission, usually so it can be sold, leaked, used for extortion, or exploited for competitive advantage. Beginners sometimes imagine exfiltration as one huge download that is obvious and easy to catch, like a truck backing up to a warehouse. In reality, attackers often try to hide exfiltration inside normal business workflows, spread it across time, or stage it internally before moving it out. At scale, meaning across many systems or large volumes of data, this becomes both harder to detect and more important to detect quickly. Our goal is to learn the conceptual patterns that show up when data is being prepared for theft and moved out, and to understand why advanced attackers choose certain techniques to reduce visibility. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at Cyber.Author.me in the Bare Metal Study Guide series. A useful starting point is to remember that exfiltration is rarely the first step. Attackers usually need access, privileges, and knowledge before they can steal data effectively. That means exfiltration often comes after internal discovery and lateral movement. The attacker has mapped where valuable data lives, identified which accounts can access it, and found pathways to move it. Exfiltration also often follows staging, which is when the attacker collects data from multiple sources and gathers it into a smaller number of locations for easier transfer. Staging is important for beginners to understand because it creates patterns that can be detected before data leaves the organization. If you only look for the moment data crosses the boundary, you may miss earlier signals. If you can detect staging, you can interrupt the theft while the attacker is still assembling the package. One of the most common exfiltration patterns is unusual access to sensitive data sources. This might look like a user account reading far more files than normal, accessing data repositories they do not typically touch, or querying databases in volumes that do not match their role. It is the difference between someone browsing a few documents they need for work and someone systematically collecting everything they can reach. The challenge is that legitimate business tasks sometimes involve large data access, such as audits, backups, analytics, or migrations. That is why context matters. The suspicious pattern is often not just volume, but a mismatch between the account's usual behavior and the resources being accessed. Another common clue is time. Large-scale data collection at odd hours, such as late at night or on weekends, can be meaningful, especially if it is inconsistent with normal business operations. Staging often creates distinct signals because it changes where data resides and how it is handled. Attackers may copy files into temporary directories, create archives, compress data into bundles, or rename files to hide their content. They might gather data onto a single workstation or server that they control more fully. They may also create multiple smaller bundles to avoid triggering size-based alarms. For beginners, the key is that staging involves transformation and consolidation. Data that was scattered becomes centralized, and files may be packaged to make transfer easier. That packaging can show up as spikes in disk usage, unusual file creation patterns, or sudden growth of archives in locations where that behavior is not typical. Even without deep technical detail, you can recognize staging as a phase where the attacker prepares the data for movement, like packing boxes before loading them onto a truck. When data is moved out, the attacker must choose an exit pathway, and advanced attackers often choose pathways that look normal. Instead of using a strange protocol, they may use common ones that blend into regular traffic. They may upload data to cloud storage services, collaboration platforms, or external servers that resemble legitimate business destinations. They may send data through encrypted channels so that inspection tools cannot easily see the content. They may also use small, repeated transfers rather than one large transfer, which is sometimes called low and slow exfiltration. This technique is designed to avoid threshold-based alerts. At scale, the attacker might still need to move large total volumes, but they spread it out over time or across multiple hosts, making any single transfer seem less suspicious. For defenders, This means the detection challenge shifts from spotting a single huge event to recognizing patterns across time, users, and systems. One pattern defenders watch for is unusual outbound data flow from systems that typically do not transmit large amounts externally. For example, a database server that usually serves internal requests might suddenly begin sending large outbound traffic to an unfamiliar destination. Or an employee workstation might suddenly upload gigabytes of data outside of normal usage patterns. Even when traffic is encrypted, volume and destination analysis can reveal anomalies. Timing patterns matter too. If a host repeatedly sends data bursts at regular intervals, especially during times of low user activity, it may indicate scheduled exfiltration. Another clue is new external destinations. If systems begin communicating with domains or IP addresses they have never used before, that can be a sign of an attacker establishing an exfiltration route. These signals become more convincing when correlated with earlier signs of staging or unusual internal access. At scale, attackers may distribute exfiltration across many endpoints, which can make each individual host look less suspicious. For instance, if an attacker compromises multiple user accounts, they may pull data from each account's accessible resources and exfiltrate smaller chunks from each device. This avoids creating a single obvious hotspot. Detecting this requires a broader view, which is where NDR and centralized logging become valuable. Rather than watching one host, you look for a pattern across many hosts, such as a sudden increase in uploads to a particular service or multiple hosts communicating with the same new destination. This is also where identity context matters. If multiple accounts that share no business reason to access certain data suddenly show similar access patterns, that clustering can reveal coordinated theft. In other words, scale changes detection from a single device problem into a pattern recognition problem across the environment. Attackers also use techniques to reduce the chance that defenders can trace what was taken. They may delete staging files after transfer, clear logs where possible, or use ephemeral infrastructure that disappears quickly. They might also use account misuse instead of malware, so that actions appear as legitimate user activity. This connects directly to living off-the-land tactics. If an attacker uses built-in tools to compress files and legitimate cloud services to upload them, defenders may see only normal utilities and normal destinations unless they correlate the context. This is why a mature defensive approach emphasizes behavior and intent. Large-scale exfiltration almost always requires unusual combinations of access, staging behavior, and outbound movement. Even if each component looks plausible alone, the sequence is often abnormal. The key is to look for the story, not just the individual events. A common misconception is that data exfiltration always means stealing documents, but data can include databases, credentials, source code, emails, configuration files, and even backups. Backups can be especially attractive because they contain large amounts of consolidated information. Exfiltration can also involve copying data to unauthorized internal locations first, such as moving sensitive data from a restricted server to a less monitored workstation. That internal relocation might not cross the perimeter immediately, but it is still a significant warning sign. Beginners should also understand that attackers may exfiltrate small, high-value data rather than huge volumes. For example, stealing a set of credentials, encryption keys, or proprietary designs could be devastating even if the data size is small. Therefore, detection should not rely only on volume. It should also consider sensitivity and access context. Defensive detection of exfiltration is strongest when it integrates multiple signals. EDR can reveal local staging behavior, such as the creation of large archives, unusual file access sequences, or suspicious processes interacting with sensitive directories. NDR can reveal outbound data flow patterns, unusual destinations, and repeated transfer behavior. Identity logs can reveal unusual access patterns, such as accounts querying many files, accessing data outside of their normal scope, or authenticating to systems where they do not usually work. A SIM can correlate these layers to produce a higher confidence alert. For example, if a user account suddenly accesses many sensitive files, then a workstation creates a large archive, then the network shows a large outbound upload to a new destination, the combined story strongly suggests exfiltration. This layered story is what makes detection defensible and actionable. When thinking about response, the beginner goal is to understand prioritization rather than specific technical steps. If you suspect exfiltration, you prioritize confirming what data was accessed, whether staging occurred, and whether data left the environment. You also consider whether the account involved has been compromised and whether other accounts show similar patterns. Because exfiltration can be ongoing, timing matters. Quick containment may prevent additional data loss, but it must be balanced against the risk of disrupting legitimate operations. This connects back to earlier lessons on automation and overtrust. Automated blocking or account disabling can stop a theft quickly, but it can also cause harm if the alert is wrong. A mature approach uses confidence thresholds and layered evidence to decide when to act immediately and when to investigate first. By the end of this lesson, you should be able to recognize data exfiltration as a multi-step story that often includes unusual data access, staging through consolidation and packaging, and outbound movement designed to blend into normal channels. At scale, attackers may spread exfiltration across time and across multiple systems, making detection more dependent on correlation and broad visibility. You should look for mismatches between accounts and the data they access, unusual transformation and bundling of files, and unexpected outbound data flow patterns, especially to new destinations or during unusual times. The decision rule to remember is this: whenever you see unusual access to sensitive data, immediately ask whether staging and outbound transfer patterns are present, and treat the combination of abnormal access, packaging, and external movement as a high-priority signal of exfiltration in progress.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.